So every lesson you can remind me that. So I set up this one, and then after that you can have a look again. Okay.
Sure.
Okay. Now here you go. So you think that if you get, I can stop record on is better on.
Okay.
Okay, because I already record on the YouTube, so it's easy, right?
Yeah.
Okay, now I come back this one. So for the motion in breath, for the motion in straight line, that means we care about what? We care about only one line, only one line. So direction, we have only two direction. The first one, that means to what, and the second one backward, that's all, right? And then we have maybe the motion on the vertical direction, along the line, and maybe the horizontal, and so on. But now you know that in mathematics and quality has only sign and magnitude. It's called scalar quantity. Scalar quantity that we care about only the value, right? But in the physics, in the mechanic, we care also the direction.
Yeah.
So if one quantity care about the magnitude and direction, that's called the vector. That's all. That means in the mechanic world or in the physics world, we care about the magnitude, direction also. So that's called the vector quantity, right? But if we have only the value, that means the mass and the time and the energy and power and so on. So they are scalar. Here, there's two kind of the quantity we care, right? And then we care about what? For the mechanic, we care about the distance and position and displacement. And here, in this case, you care about the difference between the concept distance and displacement. And distance just means the total distance traveled by the marble or any object at any time does not depend on its direction. That means in this case, we can see that it's called scalar quantity, right? And now, if we move on the next one, the position here, the position related to the position of the object. That means maybe we care about the zero position, maybe the earth plane or the hand or the any origin points, something like that. We define that the fixed original or with the zero position. And then after that, we have the value of the position may be positive or maybe negative, because we define the direction of the number line for them. So that's why if you define the positive direction in when the object on that direction, that denoted by positive, or maybe up on the opposite side, we can denote by negative, right? Understand this one? Okay. And then we care also about the displacement. Displacement, what does it mean here? Displacement just means we take the vector, from the initial point, displacement from the initial point to the final point. So that's why maybe the distance traveled by the object is positive, but the displacement may be zero. It's okay, right? That means you understand displacement is different of the vector from the final position compared to the initial position. Okay.
Direction and distance from the initial point to the final point.
Yeah. No, displacement from it's a vector.
Yes.
It's a vector. Yeah, it's a vector.
And
connected from the initial point to the final point.
Distance is is
Distance is total. Is a total path. The sum of all the distance by the object.
so
Okay.
okay.
Okay. Here, for example, I can show you on the graph on the figure 1.1. Look at this one. The distance is the total of the length here. Total of the length here, right? Total of the length. All of this one. Okay. Fine.
Yeah.
The distance, but the displacement, but at this point, that's only the vector, this one only, the blue vector here.
Yeah.
The initial point here and the final point here, that's a vector here. Just so. You got it?
Yeah, got it.
You understand that?
Yeah.
Because they don't care about the on the pathway. They care about the initial point and in the final point. That's all.
Got it.
Okay. Okay. Fine. Now next. So here denoted by, so you know that in the physics world, mathematics world, they don't care about the unit, the system of the unit here, but the physics, they care about this one. They care about this one. The distance, meter, centimeter, kilometers, different. But you can tell me 5. The distance is 5. It does mean nothing. So you should include the 5 centimeter, the 5 meter, or the 5 kilometer, right? And also the mass also, the kilogram or gram or ton or something like that, right? Remember this one. And also denoted by notation and unit for the mechanic. Here we can denote by anything. You can denote by any letter you want. And the time, maybe you take the time is t. The velocity may be the v and maybe u. And a here for acceleration. That means the first letter, that's some kind of this. But you can denote by another letter. It doesn't matter. Okay. Speed and velocity. Speed is scalar quantity, and I tell you that speed is the magnitude of the velocity.
Direction. Yeah.
And the velocity is vector. So now you know, understand when they divided by velocity is the distance, displacement divided by time. Speed equal to change in distance divided by time traveled by. So that's why you know the word velocity. You know the word velocity. Here it consists of two words, vélo and city. You know vélo in French. Vélo is French. That means bicycle. You know that?
Bicycle.
Yeah, vélo. In French language, that means bicycle.
Okay, what's city?
And city is a city.
What? Okay.
So that I tell you the words that can consist of some kind of, maybe you can easy to remember.
Velocity. I remember.
Yeah. And also the velocity has a direction, right? When the question tell you that what is the velocity of this marble, for example? So that means you have to find out the magnitude and also direction, right?
Yeah.
That means two factors you must to find out the value. And speed that's one only, the magnitude only. Does not involve any direction. Okay. So that's when we're talking about the speed and velocity. So that means speed always non-negative. Okay. Speed always non-negative. But velocity. But velocity can be negative.
Yeah.
You got it. Okay. So that's the most important thing. Okay.
Yep.
And then we move going on. And then also, if you know exactly the thing that we do, so after that we can understand well for the graph. graph of the motion also. Here, if look at this one, if you have a graph like this one, so how analyze this from the 0 point position? But here, until the 50 and 500 position meter, but you can see horizontal line here. Look at this one. Horizontal line doesn't change the position, right?
Yeah.
So that means they address.
Yeah.
Understand what I mean?
Yeah.
So that means you always think about the analyze, think about the value corresponding to
Yep.
the correspond to graph. So that means you should learn how to understand the graph. Okay, understand the line, understand the slope, gradient, understand the position, understand the value corresponding to horizontal line, x-axis, or maybe the vertical line, the y-axis. Okay, and from the graph we can find out speed, distance, position, and anything. Okay, got it?
Yeah.
Okay, move. Now look at this one. When we have the motion in the straight line, we have an average speed and average velocity. The average speed, that means the total distance traveled over total time taken. The time taken here, in this case, you should think about that include the relaxed time, right? Here.
Yeah.
In this case, the total time taken here, include the rest time. Rest time. Understand this one?
The total time.
Yeah. Yeah, that's right. That's right. And here, average speed, we have only concept of average speed because we care only magnitude only. So that's why involving two distant. Okay.
Got it.
Okay, fine. And average velocity. Look at this one. Average velocity here, we care average velocity. We care about for the displacement. Understand this one. We have two concepts of average speed and average velocity.
Yeah.
Velocity correspond involving displacement, and average of speed involving distance. Okay. Okay, now look at this one. We have the concept of velocity at an instance. An instance has been at once, immediately, right?
Yeah.
If you see the graph here of the motion, the upbeat trajectory of the motion here, at any point, that means at any time, you can see position here, the tension of the point, the tension here at any point will give you the gradient of the graph, right? The gradient of the graph will show you the trend in position, because here the position, the trend position, that means to give you the slope here, give you the velocity, right? This the slope, the gradient of the tangent of the graph at this point P will give you the velocity. If the position here, the trend of velocity, and then the trend that of acceleration, the gradient of the graph speed time will give you the acceleration, right?
Yep.
Okay.
Then this one is just 0.
We can this.
This one? Or do I have to move it up? Because it's just straight. How do you find the... Okay, got it. Okay, I got it.
Okay. Continue.
Yeah.
Okay, for the graph of velocity and time, according to the graph of velocity and time, you can find out the value of acceleration. Okay. Because you know, if the graph of the line, a straight line here, you can write down the equation of the graph. That means you remember that y equal to m times x. But see, you understand this one?
Yeah.
So n here, that's slope, right? That's the gradient. And you can find out the gradient here for the graph, the velocity time, the gradient here is presented by acceleration, right?
Yeah.
Okay. And see in this case here, the y-intercept, right?
Yeah.
Okay. Continue. So on the graph here, after that, maybe exercise 1B, after that you can do for me, right? Here I keep going on for the theory only. The acceleration here in the language, acceleration just means the training velocity of the time taken. You got it?
Yeah.
This one, the rate of velocity train.
Average acceleration.
This one, yeah. Okay.
Go
And
ahead.
you know you need of this one, because velocity here you need meter per second, right?
M second. M per second.
And you
Times
denote
S minus 1.
and divided by second.
S.
So that means this one equal to meter per second square, right? Right, understand that? Understand that, this one.
Yeah. Essentially, it's just ms minus 2.
Yeah. You can denote it by the index
Yeah.
notation. Okay, great. And then now, and then here we can see the graph. See graph here, you understand well from A to B. Look at this one. No, wait, look at this
4,
one.
2, 6. That's so 6.
A to B here, that means the increasing velocity, right?
Yeah.
And the slope like this one from AB, you can find out the slope of AB. That means in this case, this period, you can find out the 6 divided by 5, right? Yes, divided by 5 is acceleration.
Yep.
And then BC, now tell me about
BC is
BC.
just 0. Acceleration is
The
also
speed constant, right? Speed is constant.
Yeah.
The speed acceleration is zeros, okay? A constant. And then what about the CD?
Negative.
Negative. So what does it mean?
It's going the opposite direction. The speed, sorry, is it? You talk about the speed, so it's there's like a decrease. Maybe it's decrease in acceleration. For this is from 10 to 0, so 2.5 negative 2.5. This the acceleration meters per second minus 2.
Yeah, but minus, what does it mean here in this case?
It's meaning that there's like a slowdown, maybe. The speed slow down every time until it reaches 0. Because speed, velocity. This is velocity.
Okay.
Because it slows down probably. The decrease in speed. Yeah.
Okay. So negative just means deceleration. It's not
Yeah.
acceleration, right?
Yeah. Sort of. Technically. Yeah. Technically. Technically, yeah, there's a deceleration. It slows down eventually. Yeah, technically it decelerates. Technically.
Okay. You got it?
Yeah.
Fine. And then we move on the next one. Does that mean if you understand well on the graph? So this means easy to you to follow by the next step.
Okay, got it.
And the sign association you understand well, that maybe the sign is positive. This means increase, maybe the decrease is negative. It depends on we did not buy, right? Right?
Yeah.
And furthermore here, you can understand the graph of this question on the finger 1.13. And you can explain for me here all A, B, C, D, E. And now you can, which graph below could represent the distance time graph, velocity time graph, and acceleration time graph of this motion.
Velocity time. Distance time graph. I believe E does a good job with the distance time graph number. The velocity time graph would suit, I would say, too confident. Let's see if we know that. There's a possibility that like it goes up and then it goes down further. Velocity maybe a. It's a velocity after all. It's not speed. And acceleration time graph. Acceleration time graph. Never mind. Take back my word. This E fits I itself. A suits the last one. And I think velocity time graph. Oh. That's a hard one. Nothing D. That's my response to that.
Okay. You got how to find out the distance graph time is E. E just means okay, go down. And the velocity is D. Why is D? Because from the go up, that means the speed is increasing, right? And the go down, the speed in decreasing.
Yeah.
Okay.
Yeah.
But now for D here, you see that the D is the always the same direction. That means the same side.
Inside, yeah.
That means gradient is always the same side.
Yep.
That's correct or not?
A car accelerates.
Same sign just means the direction it doesn't change, right?
Yes.
But think about E. E maybe direction is change direction or not in the whole journey, on the whole journey.
It's the. I mean, there's like a slowdown. Oh, it instantly slows down technically. Maybe for the scenario, maybe. Or slows down immediately. It has to slow down. So B, C, or E for this scenario. Time distant. Time. Okay, so it's either B, C, or E. Maybe B, more sudden, because it's slowed down very quickly. Maybe C would be more accurate because of the moment of inertia. Because when you touch the tire, when you stop, it is completely stopped.
Because you see that here, the set of traffic light, right? They accelerate the maximum speed, and then it starts slow down to stop the second set of line. So
C or B.
you think twice, think more about this.
Velocity. B. I reckon B. Velocity time graph maybe. It doesn't go back though. So D would suit it. Acceleration time. E kind of suits it because I mean, there's a quick acceleration and there's a slowdown. Maybe this, maybe B or E. I think B is more immediate. Or C. I mean, the acceleration meets it 0. I mean, fine. C. BDC. I reckon that. I reckon that's B. BDC. Which one?
Yes. You got it? The
B.
B now, look at this one. B, so why you choose a distance time with B?
Because it's very, I mean, the distance covered very quickly in such a short amount of time, but then it has to slow down. But then the acceleration, I think it's more suitable. It's B or C. I'm not specifically sure. I think it's either B or C. Maybe C fits you more than B because it's maybe distance covers. If I see D, B, it's because D is easy because it has to be positive and then it goes down. B is because they have a short time of acceleration time, very short, right? And there's there's a very short acceleration moment, as you can see, very short, very quick. It starts to slow down a bit. And the C is because it takes a while to start up and then there'll be some kind of moment of inertia, maybe at the end. I mean, like, it barely touches, like when you, here, There's this wheel. When it stops, I mean, it's a very short time, brief time it stops because it's going real quickly. It goes and it stops like until here because of the quick speed. Too quick. When you push something, you expect it to stop, but it puts a bit forward. So I think C. We go with I. Actually, C will go 1, D will go 2, and 3 will be B. That's my reasoning. So it's correct.
Okay, so now we let this one. After that, we can come back that if you can see what is the difference at the beginning of the course and after you study after the chapter 1, right?
Okay.
We move on. And here on the exercise 1C here, at the similar one, you can find out the value of acceleration on the graph of velocity and time, right? For each stage, A, B, C, D, E, you can find out as I told you before, right? This one you can do at home, okay?
Okay, sure.
Okay.
The chapter 1.
The chapter 1 here, this one, you can just only apply only, right? Now, I told you that if the area to find out distance and displacement. Look at this one for the graph of speed.
Got it.
Speed and distance here, right? But from the graph of the speed time here, the second one here, you can find out also the distance traveled by on the whole journey, like this one, right?
Yeah.
They denoted by from 0 to 3 here. That means the area under the graph of the light here is this one.
Yeah.
And here, this one is the value of the distance area here of this one, of this triangle here.
Yeah, technically.
Right. That's easy to figure out this one. But on the curved line only, the also have the same velocity and the same value if you denote it by the speed and time graph. Remember that only on the speed time graph, right?
Okay. Only speed time graph.
Yeah, the distance is the value of the area under the line, right? Only distance. Okay.
Got it. Only in distance. Yeah, distance.
Yeah, only here.
Speed. Yes. Yeah. Finding the distance.
Thus, only we apply for the speed time graph only. Look at this one.
Yeah, on speed time graph.
Only speed time graph here.
To find
all of here, all of here, all of here. The area of this one is represented by the distance traveled by. Okay.
Yeah,
okay, fine. That's important thing for you. The first case, the triangle here, 1/2 of dt, and here the velocity constant is the v times t. That's easy for you, right? Distance equal speed times time, okay?
Yep, got it.
But for increasing here, like trapezium, the area here 1/2 of the v1 plus v2 times t. Okay.
Yeah.
So all of this one, think about the area under the line on the graph speed time. Okay, fine. Continue. An example here that's easy to find out. That means easy to cut off the graph.
Yeah.
Right.
And find out like.
Yeah. See, so I can find out the area. But if you have the graph of between the velocity time graph and the time exists, so understand well which one will give you the back, right? The start and the finish and the back and so on. For example, here, the sun you walked east for 6 seconds and 2 meters per second, and then west for 2 seconds, and draw the diagram of journey and see the diagram and the speed time graph and the velocity time graph. So what is the difference between the velocity time graph and speed time graph? Look at this one. Here, some new journey is illustrated below here. The first one, I think, is easy, right?
It can go back, like it can go negative.
Yeah, yeah.
Speed
It's a
cannot
negative.
go negative. It has to be positive.
Yes, yeah. Look at this one. Here, speed time here. Corresponding, you can see the graph time from 0 to 6 seconds. The speed is constant, okay? And after that, the growth immediately to 1, right? Yeah. And keep constant from the second 6 to 8. So that's speed time graph. Understand this one?
Yeah.
And then if you want to find out distance from speed time here, you can take the total area, right?
Yes.
Or the 2 rectangle. That's all.
Yes.
And then the velocity to graph time. Now look at this one. What is different here? Tell me.
It goes negative.
Yeah. Why? Why? Now explain for me.
My hypothesis is that, my opinion is that they went backwards, because in this mathematical world, it doesn't really have a direction. Unlike velocity, speed has no direction. Velocity has. When it turns the opposite direction, when the opposite direction, it becomes negative. Unlike speed, you get the total, and velocity, you get the inertial to the direction distance of the initial point to the final point.
And then in this case, but you're talking about the velocity, that means in this case we have the positive and negative, right? Yeah. So that's why the area here is the 12 minus 2 is 10. That's it displacement from the start in meter, okay? So you understand why the difference between distance and displacement?
Yeah.
Okay, so remember this one. If you study on the speed time or velocity time graph, okay? Remember that? And for estimate the area that mean here speed time like this one, I think that for the curve line, you should using the integration to find out the area under the curve line. But for integration, the next time I will teach you more about this one, but it's difficult. We cannot cover in this case. Okay, that means they divided by this graph to smaller species. That means smaller species means like this one. Look at this one. The trick is that, for example, by here, small pieces like this one, right?
Yeah.
And now look at this one. So each piece here like a trapezium, right?
Yeah, you make an approximation guess.
Yeah, that's right. And then after that, you take the sum all of this one, all of this trapezium here, and you can find out approximately about the area.
I don't know calculus yet. I don't.
Yeah, some kind of this one.
Since I don't know calculus, I will make an approximation guess.
Yeah. Also, you know that when you divide them into smaller, as small as possible. So this means as precise as possible. Right?
Yeah.
Okay. Fine.
That's a bit ridiculous, but
okay.
Yeah.
Now we move on.
Yeah. For an approximation guess. Actually, I want to learn graph after circuit theory. Graph, because I need to know how to learn how to do parabola. You know what's a parabola?
Paragraph?
Parabola.
Oh, which one?
Parabola is like the ones that have a curvy line and has
parabol?
only one.
You know,
Parabola. I mean, parabol.
Yeah, but
parabol.
You know the which difficulty for you for parabol?
Finding the equation.
Finding the equation?
Yeah, like how do you find the equation? I forgot. Like,
the equation of this. So you know the equation of this one. Just only like this one. Ax square plus bx plus c. That's all. If you want to find out, that means you can find out for me A, find out for me B, and find out for me C.
Oh. Right?
That's all. Is a form of the parabola like this one.
Yeah, but I have to find out how do you find out like
Furthermore,
problems.
yeah. Furthermore, here you want to understand more about the graph parabola. Here you can, by using the dash mode, you can understand well this one. Right, by dash mode here, you will see.
Yeah.
Look at this one. Y equal to x squared. You see the graph.
Yeah.
And then you equal 2x. You see graph.
Yeah.
That's one. You can see graph.
Okay. Yeah.
So this be the moving.
C is the y-intercept. X is what? What is x? What's x by itself? What is x?
Axis means horizontal axis.
What's x squared then?
X squared here. When x increase, right, and y may be increased, but for the positive part of x, it's okay. But for the negative of x, when x increase and y decrease.
A is the gradient.
A just mean the factor. That's all. Look at this one. 2, right?
Okay.
And 5, right? And 10, right?
Why though? Actually, why?
Here.
10x squared.
This one. But now, how to find out on the graph? Look at this one, right?
Yeah.
Here is 1x squared. So that means, look at this one. I show you that when x is 1, right? X is 1.
Yeah.
Right? So now the graph here will be 1. Okay?
Yeah.
So this means the factor here, coefficient here is 1, right?
Yeah.
If I increase 2, look at this one, 2. The difference.
Touches 2.
2. That means when x is 1, right? So now the point here is 2. So that means the factor is 2. Okay?
Yeah. So
if
it's 3.
If 1 and 3, that is the same one. 3 is same one, right? You got it?
3 still, oh yeah, 3 is here.
Look at this.
Yeah.
You got it.
Okay, got it. Okay,
so that's easy to find out, right?
Okay, so yeah, that's the one. Okay, got it. So the x squared is the x is just x.
Yeah, for them even want to t for time, right? Even want to denoted by t for time, you got to not take x, you can take y. I take t is okay. T is the same one, right?
B equals to what? ax squared plus bx plus c. C is a y-intercept, I understand. What's bx? What's b?
B is depend on if you want to complete, that means squaring, complete squaring. You can find out the B.
So
here,
x
look at this one.
plus.
For example, here, look at this one, x squared,
Yeah.
right? Plus 1 is the correct, right?
Yeah.
But now if you want to add here, plus x here, right? That's different. And minus x here is different, right? And minus 2x here, that's different. That means if you want to find out B, right?
Yeah.
Okay, look at this one. I can tell you. That means here the mathematical one. Here, look at this one. X squared plus 2x plus 1 for the one. So this one here, like x plus 1 square. Right.
Yeah.
Got it? And now x squared is a line, it's the same one like x squared. I would like to tell you what the translation here. Now the first one, look at this one. Right, you got it?
Yeah.
And then the second one, I add another one. Second one, here, y equal to x plus 1 square. Now, you can find out for me the relation between them.
Oh, they move by
what?
They move like into like left. They move left. They have the same gradient, but they move left to left. Oh, so So this is just an expansion. Ex plus c is just an expansion of this. Let's okay, got it.
You got it?
Yeah, let's go back to physics.
So that's why if you understand well here, just call the transformation of the graph. You come back to the word transformation of the function. You can understand all of this one.
Right.
Transformation of the function, right?
Yep.
The graph function. Okay. So that's why if you understand well this one, so that's why you can understand well B, right? Yeah.
Yep.
Okay. If I would like to tell you more about this one. Y equal to x plus 1 square minus 3. Right. Yep. You got it? What a difference?
Yeah.
To keep the same graph of second one, x plus 1 square, and then move down, right?
3.
Go down 3 units. Okay.
Got it. Yeah, got it.
Okay. So now it's easier to, I like to show you here that when x squared plus 2x minus 2 here, that's the original function here, this one.
Yeah.
That's like this one. And then you can simplify that, as I tell you. Understand what I mean?
Yeah.
You got it?
You got it.
Okay. And is that easy to determine about the B? And A is easy, and C is easy because we replace substitutes x equals 0, right?
Yeah.
Okay, fine. Done. Okay. So by using that small graphing calculator, you can understand all of this graph and the translation. Okay. Next one. Here, exercise 1D here. For the 2 cars and traveling along the street, you can find out the acceleration, the total distance, and also average speed, right?
Yeah.
Okay. So at home you can do this one for me, right? Okay. Got it?
Yeah.
Okay. Fine. Here, you know, the question here on the real test, when they denoted by the Cambridge AS A-level mathematics 9709 paper 4 question 5 November 2005 something. Okay, remember that?
Yeah.
Okay, so this one they take from the real test of the Cambridge one.
Okay.
Okay, fine. Next.
That's cool.
Yeah.
That's like wow. Okay,
yeah.
so Cambridge test.
Yeah, that's right.
Level.
That's real test. That means you can got it. Okay, yep. So for today, we brief now, right? Now, key point. We understand well the vector, right? The vector with magnitude and direction.
Yeah.
For example, displacement, position, velocity, and acceleration. And also we study about the scalars. The scalars we care about the magnitude only. For example, distance.
Isn't it constant?
Yeah.
Another word for constant.
No, a scalar that means that's only the magnitude only, just without direction.
Oh, no, okay.
That's all. That's all. That's only magnitude. That means without direction.
Well, yeah, okay, magnitude without direction.
Yeah, magnitude only.
Not constant.
Yeah. So it's not like constant. They're constant different kind of. If you here's a vector here, the two kind of the scalar only one kind of. That's all. And then look at this one. The vertical one is toward the center of Earth because due to gravity. Understand that?
Yeah.
Okay. And the horizontal is a perpendicular to the vertical.
Yep.
So that means for every motion, each motion, we can consider two directions. One, followed by horizontal. B, followed by vertical one. So we take about the graph on the coordinate, the coordinate O, X, Y. So for horizontal direction, how to understand the motion, and follow the vertical, and how to understand this one. They are the component of the total motion. Okay. And diagram here, look at this one. The diagram plays important role. The diagram motion, first one is position, zero position, and positive and negative position, right?
Yep.
Understand what I mean? That means depend on the definition. Okay. The mean position of the direction. Here, the second one is the velocity. Velocity may be the go the positive direction, go to negative direction, right? And then also you care about for me the acceleration. Acceleration we care about the positive also and negative also. It depends on the positive velocity. If speed increasing, the acceleration will be positive. If velocity speed decrease, this means acceleration is negative. Okay.
Yeah.
But the velocity is followed by the negative direction. Inversely, the speed decrease. That means acceleration is positive, and speed increase, the acceleration will be negative. That means it depends on the direction, positive direction we care about. Okay. And then, and then the average. We have a three kind of average: the average speed, average velocity, and average acceleration. Average speed involving distance and divided by total time taken. And remember here, pay attention here, I told you that the total time taken here includes the realized time, right?
Yep. Yes,
and average velocity equal to displacement over time taken. And in this case here, we care about the displacement.
Yep.
And then also the average acceleration here, the change in velocity here is time taken. That's okay? You got it?
Yep.
Okay. Here, next for graph. Understand well for the graph. That's very most important thing. For position time, here gradient of position time will give you velocity, right? And area is nothing useful in this case. But for the velocity time, the gradient will give you acceleration. And area will give you displacement. Understand that? When the graph, look at this one, graph under the horizontal line, horizontal axis. So the area of the graph will be negative, right?
Yeah.
The graph above time axis, the area will be positive. And remember this one for me. And then the distance time here. For the distance time here, look at this one, gradient will give you the speed, right? An area of distance time is nothing useful. But you see the speed time, the gradient is magnitude of acceleration, right? And area is a distance. Okay. Right?
Got it.
Okay. And so now I think that we stop for today, this one, right?
Yeah, okay.
Because the next time maybe it's modified. So today you got all of this one, understand this well, this one or not?
Yeah.
Okay. What?
I got it.
So now I think that you do the homework for me.
Sure.
As I told you before here, the homework here, you did this one. I think it's a better for you for practice, right?
Yep, I think it is.
And look at this one at the end, the 10, 11 is a question taken from the real paper, right?
Yeah.
Okay, I think it's good. Okay, thank you for today. I think that we stop for today because we stop at chapter number 1. Okay, fine.
Okay.
And see you next time.
See you on Tuesday. Bye.
Okay, bye.
Yeah, to end the stream.